So now that we have talked at length about probability, let's look back at the concept of independence that we first talked about back in the very first week of this course. Now we're going to look at an actual formula to help us to know if events are independent. So we have talked about the fact that events are independent. We can use the multiplication rule. But no matter what, we can use the general multiplication rule. So what is the obvious difference between these two? This one I'm taking the probability of B, and this one I'm taking the probability of B, given that something else already happened. So how would I know two events are independent? Well, if the probability here and here are the same, then wouldn't it make sense that they're independent, because this only works for independent events? So mathematically, that's saying if the probability of B is the same as the probability of B given A, then events are independent. Or it could be I'd choose A and A given B. It really doesn't matter which one goes first. It matters that this value is the same. So probability of B and B given A. So essentially we're saying, is it the same no matter what happened before that? So let's take a look at a practice together. I'm going to determine if all biology majors have to take statistics and programming in college. And by the time they're juniors, 52% have taken statistics, and 23% have taken programming, and 7 have done both. The question is, are these independent events? So I can show this two different ways. I can say the probability of taking statistics, and then I'm basically asking the question, is that the same as the probability of taking statistics given that I have taken programming? Same thing over here. I could say, instead of statistics, I could choose programming. Is the probability of taking programming the same as the probability of taking programming, assuming I'm taking statistics? So on the left side, the probability of statistics is 0.52 because they told me that. On the right side, this is a conditional probability. Remember, this is given. So now the numerator would have to be people who have taken statistics and programming, given to me, 0.07. And the denominator would be only people who have taken programming, which is 23%. So of course I'd have to do a little bit of math here. So using your calculator, if I divided 0.07 by 0.23, I get 0.3043. Obviously those are not equal. Therefore, no taking stats and programming are not independent events. Not because they are not equal. So if they were equal, then they would be independent. Again, I can show that the exact same way using programming instead. And so programming would be 0.23, which was given to me. Again, now I'm looking at a conditional probability of people who have taken programming and statistics as my numerator, 0.07. And my denominator would be people who have taken statistics, which is 0.52. Again, I have to get my calculator out to do a little bit of math here, but this turns out to be 0.1346. And again, those aren't equal, and that gives me the exact same conclusion as I had before. So let's look at events like flipping a coin and rolling a die. Are these events independent? Well, if I take a look at the math, I can say the probability that I roll a 1 is 1 out of 6. The probability that I roll a 1, assuming I've already already flipped heads when I flipped a coin, is still 1/6 because it doesn't matter what I got here. It's not going to affect the outcome when I roll a die. So are they independent? Yes, they are certainly independent. Here's a question for you to try on your own. We're dealing here with wondering if preferring a particular science, chemistry, physics, or biology, is related to the student's preference in foreign language, French or Spanish. So students were surveyed to establish their preference in science and in foreign language courses, and the question is, does it appear the preferences are independent? So what I want you to do is I want you to choose an outcome within the languages and an outcome within the sciences and decide if the probability of one of those events occurring is the same as the probability of that same event occurring, assuming something else occurred. I don't want to give you which ones to use because there's a lot of different ways to show this. So even if you don't choose the ones that I choose in the answer, it doesn't mean that you're wrong. You should end up with the same conclusion even if your computations don't work out the same. So press pause, try this question, then press play to see how you did. Okay, so what I did is I chose to look at biology and biology given Spanish. So let's look at biology first because that one's an easy one. 52 students prefer biology out of 136 people or students who were surveyed. That one's the easy one. The second one is probability of biology assuming that they've taken Spanish. So again, remember the numerator is people who are in both, which means biology and Spanish, which would be this 44. And the denominator is just Spanish, which is 102. So 44 over 102, which I got to be 0.4314. Now, again, what I've said is even if you didn't choose biology and biology given Spanish, it doesn't matter because you should end up with two values that are not the same. So again, notice the way I've written my conclusion. The conclusion is that they are not in fact independent. There appears to be some sort of association between the variables. So we'd say they're not independent. Now, keep in mind that I could have shown the exact same thing by proving the probability of French does not equal the probability of French given, say, physics, or any other number of ways. So there's a lot of different ways that you could have done this. This is just one of the ways that I chose.